We're now on chapter 2 in statistics 2, and I want to start with something that you've learned last year. So, if you remember, if x is a discrete random variable with probability of x being equal to xi equaling pi, then the expectation of x can be calculated by doing the sum of the product of each one of these xi's by the probability that x equals xi. All right, you have different formulation for the same thing. For the variance of x will be, I prefer this formulation, the expectation of x squared minus the square of the expectation. So once you know the expectation, just square it over here. And for this one, depends on the information that you are provided, but you have to square the random variable first. Well, this is done. You already practiced with this. Probably you were tested on this as well. What is new here in statistics 2? What is new is that now you may have, instead of a discrete random variable x, you may have a function of a discrete random variable represented by fx. So imagine that x being a random variable, you have 2x plus 3. This is a function of the random variable. So how do you calculate the expectation and the variance of a function of a discrete random variable? Well, exactly the same way. So the expectation of fx is going to be the sum of the product of each one of the individual functions for each value xi by the probability of x being xi. As for the variance, it's also going to be the same expression. The variance of f of x is going to be the expectation of the expression square minus the square of the expectation of the function. You may be thinking, what are you talking about? This is too abstract, I'm not understanding. Well, just go to the questions that I have in the course, and with real life examples, with real numbers, you are going to see how simple this is, particularly, obviously, if you know what you're doing based on what you learn in Statistics 1. Okay, let's look at this example. Maybe this will make the understanding of what I just said simpler. Let's say that f of x is ax plus c, where a and c are numbers. So the expectation of ax plus c is going to be the sum of axi plus c, in which xi is going to vary, obviously, times the probability that x equals xi. Okay? As for the variance of ax plus c is going to be the expectation of the expression squared minus the square of the expectation that you already had calculated. Okay? Again, practice with questions. In my course, you have plenty of questions for you to practice. You have videos of me solving these questions. You'll have access to the book with many more questions for you to solve. There is no way you will miss this. Let's see some algebraic results for both the expectation and the variance. Let's say that you have two random variables, x and y. The expectation of the sum or the difference of these random variables is going to be equal to the sum of the or the difference of their individual expectations. Okay? Let this sink in. If you are adding two different random variables, the expectation of this sum is going to be the sum of the individual expectations. If you have now the difference of two random variables, the expectation of that difference is going to be the difference of the individual expectations. If you have now the expectation of random variable multiplied by any value, any number a, then this can be simply calculated by multiplying that value by the expectation of x. And the expectation of a constant must be that constant, obviously. So if you combine all of these, particularly the last two, the expectation of the example I gave above, ax plus c, is going to be a times the expectation of x plus c. What about the variance? You have to pay attention to one important detail. The variance of the sum or the difference of two random variables is always going to be equal to the sum of the individual variances. Even, again, if this is a difference, even if we're talking about the difference of two random variables, the variance of this difference is going to be equal to the sum of the individual variances. Okay? Now, what if you have the variance of a random variable multiplied by a certain number? This is going to be equal to that number squared times the variance of x. Again, in one of the questions that I have in the course, you are asked to prove this, and this is much simpler than it looks like. Okay? But in most situations, in 99% of the questions, you don't need to prove anything. You just have to use this result. Okay? The variance of a constant obviously is 0. So the variance of ax plus c is going to be equal to what? Is going to be equal to a squared times the variance of x.